how to give me a rights to share my screen.
Ma'am, just give me 2 minutes, I'll do that.
Okay.
Ma'am, are you able to share the screen now, no?
Yeah.
You're able to share the screen, ma'am, right?
Yeah, right. I'm just trying.
Okay, you can start your
Nothing happens wrong. Hello.
yes, ma'am.
The screen is visible to you?
Yes, ma'am, the screen is visible. You can just make it full screen so that
Is it visible?
yeah, it's visible, ma'am. It's visible perfectly. You can continue, ma'am.
So, good morning to all. Very good morning to all. Today I will deliver talk on electrical vehicles towards sustainable transportation. As all of you are very much aware that India as an automotive hub and which will be ranking in the terms of world's second largest two-wheeler market, Asia's third largest passenger vehicle market, world fifth largest bus and truck market, and world fourth largest commercial vehicle market. That means that India is acting as uh, means, as a automotive hub, and as the population of India is very high, then definitely the vehicle requirement in terms of the personal vehicle or two-wheeler market, three-wheeler market, as well as the passenger bus, trucks are too high. So here we have a question that as we are means the largest manufacturer of all these kinds of vehicles and users of this type of vehicles, then what problem that we are facing? And the main problem that what we are facing is related to the environment and availability of the fossil fuel. And that's why movement is towards a green mobility. So we have the question that why green mobility? As we all know that the transportation plays a major role in development of nation, both socially and economically. So there are various reasons why which leads us to green transportation. All of you are very much familiar. Just I am introducing that part. The climate change, transport emissions strongly influence air quality, rapid global increase in the temperature, and the need for reduction in the use of fossil fuel and associated emissions. And India has committed to cutting its GHG emission intensity by 33% to 35% below 2005 level by 2030. So these are the one of the reason why we want a green mobility, then energy security, rapid depletion and digging of natural resources. India needs to import oil to cover over 80% of its transport fuel, and this ratio is set to grow as rapidly because of the urbanization. Populations demands greater intra-city and intercity mobility. The other reason is a rapid urbanization. Urbanization is an important component of process of economic development, and rapid urbanization stimulates mobility needs and augments travel demand, creating a surge in demand for vehicles. So, according to this, we need a more transportation system, and however, the economic development often involves jurisdictions, uh, judicious trade-offs, and thus arises a need for green mobility solution. Electric vehicle can improve that scenario by reducing local concentration of pollutants in city. This is the main advantage offered by electric vehicle. If you look at the air quality in India city, out of 20 most polluted cities of the world, India having the 14 cities of India are the most populated city. And NOx emission is of around 36%. I think that I have got it for the 2016, but now we are at 2021. So this has further increased, and 20% particulate emissions. It means that the air quality in Indian cities are very bad. So, and other why green mobility, one of the reasons that is related with the coronavirus lockdown acting as a catalyst towards changing the mindset of people towards electric vehicle. Over the course of past several weeks since March 24, pollution levels have come down drastically. The sky is bluer than ever, and the air pure, less cleaner, and even the temperature can come down. So people are realizing that the world that realize that and would be more than willing to adopt eco-friendly transportation method to sustain our clean environment. And to maintain this progress, the customers would be more willing to give EVs serious consideration. So, post-COVID, there is likely to be a more demand for electrical two-wheelers in the low-speed category, which is what will lead the mass market adoption in India. Because in India, the mass market is of two-wheeler. Other factors which are moving towards transportations towards green mobility is the advance in the renewable energy. We all are aware that the government is pushing lots of, can say, the push to implement or to use renewable energy sources. And other is battery chemistry, technological development, advancement in the battery technology have led to higher energy densities, faster charging, and reduced battery degradation from charging. Again, combined with this, the development of motor with higher rating and reliability, this improvement in the battery chemistry have reduced cost and improved the performance and efficiency of electrical vehicles. So these are the certain, can say, uh, the factors which which has supported the transportation to move towards green mobility. Then we can define what is green mobility. Green mobility is a sustainable transportation. The green transportation, which means any kind of transportation practice or vehicle that is eco-friendly and does not have any negative impact on immediate environment. Again, they are the green transportation means they all the resources can be utilized efficiently, changes in the transportation structures and making healthier travel choice. Again, it will minimize the consumptions of non-renewable resources and increases the use of renewable sources and reuse and recycles its component. And it demands enhanced public awareness also and participations, control of private vehicles and development of vehicles powered by renewable energy sources like solar, wind, electricity and biofuels, etc. This way we can define the green mobility. How we can achieve? To achieve the two objectives of economic growth and reduce emissions requires an integrated approach based on three pillars of green mobility. The first pillar is a green vehicle technologies, development of a better mobility infrastructure. This is the most important part, and better management of in-use fleets of vehicle. How to utilize available vehicles. So these greener vehicle technologies will require the powertrain enhancement in the conventional vehicle. Again, we are moving towards green because then the advancement in the conventional vehicle powertrain technology will again further increase the performance of IC engine. A biofuel blending and hybrid and electric vehicles. Modes of green transportation, you can start with pedestrian and move to other as second is a bicycle, and the remaining all transportation sectors, that is public, service train vehicles, taxis, multiple occupant vehicles, that is carpools, and single occupant vehicles like to be replaced by EV. Then the transportation modes is considered as a green transportation mode. So, as I said that one of the mode of green transportation is the implementation of conventional or conversion of this conventional vehicle into an electrical vehicle. And if you look at the history of vehicle development, initially the vehicle developed was electric vehicle. So origin of steam engine will take place in 1769. The first internal combustion engine on the fuel is 1806, but the first electric vehicle will be introduced in 18th century. And then the first successful gas-driven engine, first gasoline-powered car in 1893, first hybrid vehicle in 19 and the peak production of EV in 1912. This was the peak time where the peak production of EV was ever in use of EVs is of a peak. Then after 1924, between 1924 to 1960, a gasoline car has dominated the market of EV, and EV get disappeared because that time the fuel is available at very cheap rate. Dominations of gasoline cars, that is 1924 to 1960, and in 1960 again the concept of time and serious design of fuel came in picture because people have realized that the availability of the fossil fuel is not the life now. And in 1970, the limited productions of EV took place. In 1980, incorporate technology advanced into a EV design, and in 1990, regeneration of EV, that is EV comes in market, and the first hybrid EV and increasing that level has been increased as the gas supply demand increases in terms of the cost. So in short, we can say that the journey is like initially we have the people are using EV, and then after in certain durations, 1924 to 1960, people have focused on gasoline, and then after further they realize that this vehicle generates high amount of emission, utilize, operate with a very less efficiency, and people have further focused on EV. And now if we look at the today's scenario, the lots of EV vehicles, electric vehicles are available in market, especially in the other countries, foreign countries like US, then the European countries, and even Japan, China. They have a good number of electric vehicles on the road. And that has been arise because of the problem caused by the ICs, dependency on the foreign oil, low efficiency greenhouse effect, that is atmospheric heating, toxic air pollutions, toxic solid waste pollutions, toxic input fluid pollutions, and wastage heat generated by its inefficiency. And if you look at the advantage and disadvantage of EV, it is a cleaner technology, zero emission vehicle, tailpipe zero emission vehicle. We cannot say that it is a totally zero emission vehicle, because when we charge the battery of EV through conventional grid, then they contribute to the emission. Non-toxic waste, the batteries are 98% recyclable, require no toxic input fluids, are highly efficient. That means all the components of the EV are highly efficient and operate with 90-75% efficiency. Benefits electrical utility, that means they support the grid utility during certain peak power demand conditions, as well as voltage restoration conditions, and low maintenance cost. But disadvantage, battery needs to be charged. This is one of the disadvantages, because you cannot have the charge. You need to charge the battery. Refueling of the battery, a charge into a battery takes more time compared to the refueling of your tank. Of course, now this disadvantage has been reduced with the development in the technology of battery. The car cannot be used when batteries are being charged. Range limitations with a single charge, and battery disposal needs to be carefully managed. Again, the cost is again a disadvantage part, because still the cost of EV is much higher, because the cost of battery will be the most dominant part of EV cost. As far as India is concerned, we can say that why we need EV. With rapid urbanizations around the globe, electric vehicles is the need of hour to serve everyone. The main thing is hybrid or electric powertrains operate at much higher efficiency at low Indian driving speed than the internal combustion engine. This is the most important part, because in India, almost all cities are highly populated, and that's why the density of vehicles is very, very high, and that's why the start-stop will be the number of start-stops for a vehicle is very, very high. Higher share of energy per Indian trip is lost in braking, which is almost recovered in hybrid electric vehicle and EV through regeneration, through the concept of regeneration. And HEVs and EVs use no fuel during idling, and share of idling time in traffic is much higher in India. So these are the certain factors which again forcing the need of EV. Again, the average range travel in India is much smaller than US, and that's why the low range problem can be again with a single charge can be further tackled. In Indian electric vehicle ecosystem market analyzed by BIS research, the EV market is anticipated to grow at the robust CAGR of 43.13% during the forecast period from 2019 to 2030. And additionally, we need to have the charging infrastructure also. So this charging infrastructure is projected to grow at a CAGR rate of 42.38%. So this will again boost the employment requirement as well. Electric vehicles are not just the way of future today. Again, they are saving the lives today, or they support the healthy life of diesel of India. If you will compare the CO2 emissions with electric cars and the diesel hybrid, gasoline hybrid, diesel, CNG, and gasoline car, you can see that the carbon emission, dioxide emissions is very less, 70 gram per CO2 per kilometer. While if you look at the gasoline and CNG and diesel car, it is very high. Even a gasoline hybrid and diesel hybrid, they contribute much. So electric car will have the less carbon dioxide emission as well as the energy input, if you can see, to run 1 kilometer in terms of megajoule is very less compared to the other vehicles. Other, you can say the other vehicles operated with the different fuels. Again, if you look at the benefits, the efficiency will be very large. Engine efficiency is 17 to 21%, while the electric motor efficiency is 90 to 95%. Of course, we can have still we can have the internal combustion engine which can operate with the efficiency in the range of 32% to 36%. But if you look at the reliability of the electric vehicle operations in terms of the moving parts, then IC engine will have more than 2000 moving parts, which is not the case with the electric vehicle. Again, if you look at the EV cost in volume, so what I am talking here, the cost of EV in terms of volume, then recently we are at this crossing point that the capital cost of electrical drivetrain has been reduced and the IC engine driven drivetrain has increased. But this is in volume, in 100K volume, we can say about this. But here we have not included the battery cost as well as the battery charging cost. And that has been included in the fuel cost, the petrol cost per kilometer, and battery plus the power cost per kilometer. If you look at this, still it takes time to reach to this crossover point. But if the EV volume is much higher and the single EV is traveling maximum of, let's say, 2 lakhs kilometer in 5 years, then definitely the battery plus the power cost per kilometer will be much lesser than the petrol cost per kilometer. But that is, of course, in terms of volume and in terms of the highest amount of kilometers traveled in a year or for 5 years. And other points that is related to the cost of battery is greatly reducing. Initially it was very high, and now it has reached near $200 per kWh to $150 per kWh, and it is expected that in 2030 and 2024 it is going to reduce to $100 per kWh. The storage cost falling rapidly, and the EV storage will also enable the grid balancing operation, that means it will balance the grid, then it will not take any power from a grid. So that promotes the use of power during off-peak times, will help the renewables to grow. Again, during off-peak times, if we take the power from renewables, and then because we know that the renewables are intermittent in nature.
Very warm welcome to all of you on our 5 years journey on this SVNIT development of residential microgrid, which we are conducting in collaboration with Typhoon HIL. And again, this call is now being recorded. Kindly mute yourself. All the participants, I request all of you to please mute yourself. Okay. Yeah, so I hope that all of you are in receipt of the timetable which we sent along with the link.
Hello?
Yeah, ma'am, just a second. I don't know what has happened. Why?
Yes, ma'am. Yes, ma'am.
Yeah. Okay, continue, ma'am. What happened?
I put some some other session is also going on.
Other section?
Session, yeah.
No, only one session is there, ma'am. You can continue on this, no problem, ma'am.
So you are not able to hear any other voice on the
No,
speakers?
no, ma'am.
Yes, madam, we are receiving another voice.
That's fine.
Okay, so yeah, just let me check this section.
I thought someone shared the screen.
Ma'am, I want to hear any other sound.
Hello? Now?
Now, okay, madam.
Okay. Everything is fine.
Yes, ma'am, please continue.
So as far as the EV cost, in terms of volume is falling definitely in terms of the battery. And battery storage we have again they also enable the grid balancing operation. And this will again, if this electric car battery will get connected to even microgrid, where we have the renewable sources, they support the functionality of renewable sources also. Because as we know that the renewable sources are intermittent in nature, and that's why their power protection in terms of voltage and currents are not consistent. But now here's the question, but do we have the enough electricity in India? As the solution is, we have the vehicle to grow from 200 million vehicle is likely to grow to 330 million by 2030. Even if the thermal power was not available, then how will we accommodate this? Then the answer is the solar power and wind power. And even a solar power, 0.5% of the Rajasthan can generate all power required by 30 million vehicles if they are all electric. So we don't have to worry about electricity. Only thing is that the government is pushing to implement this renewable energy sources of develop and use of renewable energy sources. Again, pollution will be the renewable energy to qualified vehicle and we will the coal plant, no tailpipe emission. That tailpipe emission is zero, but the CO2 emission. But of course, that is less than petrol and vehicles. So, and this are again naturally connected. So these are the certain, let's say, the advantage, certain, can say, the certain driving force in terms of the cost of energy storage, falling cost, and move towards renewable sources. If you look at the time to efficiency of conventional vehicle and electric vehicle, conventional vehicle is 13% overall, and electric vehicle is 4.56. This is why this is less, because the generation is very less. Of course, this will contribute to emission, but if we will replace this generation part, we will replace this generation part by non-conventional sources or renewable sources, then again the power or the efficiency of the system can be further increased, as well as the emission reduction will be further increased. And if we look at the economic, and if we I just some analysis of the different kinds of vehicles, and I've taken that what is the average distance travel per day by different types of vehicles. Two-wheelers 40 kilometers, three-wheelers about daily commute kilometers, not 100, maybe 200 to 250, but here I have only 100 kilometers. Four-wheelers driving, about 70 kilometers. Four-wheeler taxi, again not 120, but say 200 to 50 kilometers per day. And buses, public bus, it is again 200 kilometers. it, how much power this two-wheeler, three-wheeler will consume in terms of watt-hour per kilometer and in terms of kilometer per liter. That the power consumed in watt-hour per kilometer for two-wheelers is 14. Now, the new wheelers available in market, they are not consuming this much watt-hour per kilometer, but even lesser than this. Of course, with certain restrictions with the speed. So it may be within 20 to 25 watt-hour per kilometer. For three-wheeler, it is 18, and typical mileage it can cover 45 kilometers per liter. Three-wheelers 25 kilometer per liter, and so on. Buses will have the very less kilometer per liter average. And if you look at the energy consumptions for in 1 day total output to, can say, these regular kilometers has been mentioned over here. And if you look at the total saving with the power, if they are electrical vehicle, with the consideration that, because this my analysis is a long back analysis where when the, can say, the rate of petroleum product is 70 rupees per liter. Now it is today's it is 100 rupees per liter. So saving with respect to, and almost Gujarat government have or can say the GEB, Gujarat Electricity Board, have supported that they will charge 4 rupees per kilometer and 4.1 rupees per kilometer depending on the segment of vehicle and how much power they demand for charging. And based on that, this calculation shows that how much amount of rupees that we are saving per day if we are using this all these vehicles as a electrical vehicle. And you can realize that in bus we are saving 1,310 rupees for one bus. If we have the 200 or 300 buses running on road of Surat, you can imagine that in per day how much we are saving. Then what is EV? An electric drive vehicles, or it is electric drive vehicles, or simply electrical vehicle, is a vehicle based on one or multiple motors, electric or tractions to ensure propulsions, as well as it has a multiple number of source. An electric vehicle may be powered through a collector system by electricity from off-vehicle source, or maybe a self-contained with a battery, solar panel, fuel cell, or an electric generator to convert fuel to electricity. It means that we have the different types of electrical vehicle. I will show you in this, and that has been here. It has been mentioned with the 0 level to 1 level. 0 means the conventional vehicle, and as you move with the hybridization of this vehicle in terms of the micro hybrid EV, mild hybrid EV, full hybrid EV, plug-in hybrid EV, extended range EV, and then the full electric vehicle, then that has been marked with the 1. That means we have achieved the milestone of implementation of full electric vehicle. So under the term electric vehicle, subcategories are exist like hybrid electric vehicle. In hybrid electrical vehicle, we have the normal hybrid electric vehicle and plug-in hybrid electric vehicle, fuel cell electric vehicle, battery electric vehicle, differ in specific, but all of them are different in specific design aspect, but shares the same core electrical technology. The prefix to EV identify the variation in primary propulsions, primary energy storage unit, and drivetrain configurations. So this is based on their what type of propulsion system, whether only motor, electric motor, or only engine or motor plus engine. Then what are the primary energy source, whether the engine as a primary energy source and motor with the battery as a secondary energy source, and what type of drive configurations that you have. That means rear wheel drive configuration, front wheel drive configurations, or a four wheel drive configurations. Or you may have a single unit to drive the vehicle, or you will have the multiple electric motors to be placed in the wheel of vehicles. So we have a different stages of electrifications. Initially we'll have conventional vehicle, then we move towards the hybrid electric vehicle, Then we have the battery electric vehicle, and the other stage is the fuel cell EV. So this is our stepping towards the electrification. Of course, the hybrid EV will have a certain, can say, the limitations and a certain advantage. EV will have further advantage in terms of the amount of emission at the time of its operation, as well as this fuel cell EV that is as good as like you can say the hybrid HEV with the IC engine. Here, IC engine will be driven by the fossil fuel, while this fuel cell will be driven by hydrogen. If you look at the plug-in hybrid electric vehicles, it means that it has a plug-in point, and whatever the battery pack you have, that can be charged. And that's why this type of vehicles will be defined like it has an all-electric range also, and it can be interpreted as an extended range EV. Only hybrid electrical vehicles in which the battery pack doesn't have any plug-in facility, and that's why the charging of that battery will be through the IC engine only. You have to run IC engine. IC engine will run your motor as a generator, and then that generator will charge. Through generator, the electricity has been transferred to the battery. Now, when we talk about this hybrid electrical vehicle, we have a different configuration. As far as the hybrid electric vehicle is concerned, if you will look at this, it has engine as well as motor, and motor is driven by battery, engine is driven by fuel. Now, these four elements, or you can say these two elements, are either connected in series or parallel, or a combination of series and parallel combinations. And based on that, we have the four categories of HEV, that is series, parallel, series parallel, and the complex series parallel hybrid electric vehicle. So when we have the series electric vehicle, engine, motor, and then the battery has been connected. And the engine means engine will drive your motor or drive the generator, and generator will then supply that power to the battery, and through battery the motor get operated. So you will have the four elements like IC engine, generator, then motor, and then the motor will drive your vehicle, and the motor get power through a battery, and battery get power through this generator, and generator is driven by your engine. So this is a series configuration, but the disadvantage with the series configuration is that all elements of your series hybrid EV will have the same ratings. But if you will go with this parallel configuration in which the motor and engines are connected in parallel manner, so you can drive these vehicles only in a conventional vehicle mode, or only in electric mode, or in a hybrid mode, that is engine plus motor mode. So in that case, the size of this motor, engine, as well as battery will greatly reduce, and that is half of that rating. So this way we are getting more advantage with the parallel hybrid configuration. Of course, the series hybrid configuration is more preferred for the buses, city buses, and the parallel hybrid configuration is more preferred for a small segment car and the SUV, that means a four-wheeler. So how this parallel HEV will work, that has been mentioned over here. Of course, the operation of any vehicle will be divided in basically the three compartments. One is a startup mechanism. After startup, you have to accelerate your system, and after accelerating, when it reaches to its rated speed, it almost run at a constant speed, where the rate of change of rate of change of speed, which we define in terms of acceleration, is zero. So these are the basically, and the fourth mode is nothing but a braking mode. That means or a deceleration mode when you are reducing the vehicle speed, which we interpret as a deceleration mode, and when you stop your vehicle, we interpret that mode as a braking mode. In both the cases, you can have a facility to regenerate the power or transfer the stored or convert the stored energy in the rotating element to electricity and transfer back to the system. So as a first part, startup mechanism will be initiated by the battery or an electric motor. In certain cases, if it is, you can say, micro hybrid, the startup mechanisms will be implemented with electric motor, and then after the acceleration will be supported by IC engine. If it is a mild hybrid, in that case, almost all startup and acceleration mechanism will be provided by electric motor or in combination with IC engine. And if it is a full hybrid, startup and acceleration mechanism will be provided by electric motor. So this way, the system can start. And in a normal driving mode, again depending on your configuration, that is mild, micro, and full hybrid mode. Either the IC engine will run the vehicle, or the battery or electric motor will drive your vehicle, depending on your type of vehicle, that is a hybridization, as well as it depends on where you are running this vehicle, whether you are running it in city or on highway. When you are running it in city, it is much preferable to run your vehicle in electric mode only, and when you are running it on a highway, then it is preferable to either run by IC engine, so that IC engine can operate at its maximum efficiency, or you can have a combination or hybridization with engine and motor. The motor can share certain amount of power. Then the third mode, that is what we call it, is a braking or deceleration mode, in which the braking power will be delivered back to the battery, and the battery charging during driving. Then if it is a normal HEV, then the IC engine will provide power to charge the battery, and if it is a plug-in hybrid electric vehicle, then usually we never prefer to charge battery through IC engine, because ultimately it will again further contribute to the emission. So in that case, the battery can be charged through the grid. And if you look at the degree of hybridization, micro hybrid, mild hybrid, full hybrid, and plug-in hybrid will have the different functionalities. Micro will provide only startup mechanism, mild will provide that also, and it provides a regeneration braking also, and it uses an electric motor to assist the combustion engine. In full hybrid, you can drive at a time using only the electric motor. That facility is available with the full hybrid, that only electric mode is also possible. And plug-in hybrid, the last thing is that you can have the wall outlet for extended all electric range, and that's why the plug-in hybrid will be known as an extended all electric range vehicle. So this is based on the degree of hybridization with the hybrid electric vehicle. And if it is a pure electric vehicle, then it is simply driven by battery as a primary source, and to support the more efficient operations of EV, it may be with the hybridization of this energy storage system. If you look at the energy saving for the hybrid system, in full hybrid, the engine loss can be again avoided, because we are not keeping engine on when we apply when we have stoppage. So almost you can say that aerodynamic, rolling, and the braking will have the only the losses part, or you can say this is the amount of energy that can be transported or utilized by the aero rolling, and the braking energy will be returned back to the storage system. But if you will have the full hybrid, will reduce his engine size, decoupling of engine and wheel at the time of the stop. Because when this vehicle is running on city road, then we will have a lot many number of traffic signals where they have to stop. And if you will have the plug-in facility, can eliminate engine entirely for city drive operation. And if you will have the electric vehicle, you can see that 76% efficiency. And that's why this 76% of the power will be supplied to 29% to aerodynamic, rolling 35%, and the braking will again return back 11%. So you can add that with the 76%, and you can say that the electric vehicles are more efficient than the normal or conventional vehicle. You can look at the losses; it is very less compared to the even a hybrid electrical vehicle, where the one of the part is driving force is delivered by engine. You can see the plug-in battery electric vehicle. Uh, of course, this compartment, which I'm showing you here, this is a bidirectional DC to DC converter, battery pack, DC to AC converter, electric motor, and that will be electric motor will supply power to the wheel. This is the internal part of, or you can say the internal components of EV. And now we need to charge this battery. And to charge this battery, either the battery charger may be on board or off board. So it may be available on board or it may be available off board. So see this part, the blue color part, may be on vehicle or out of, or you can say of the vehicle. Or if they are of the vehicles, then we'll have the and the charging will be of level 1, level 2, and level 3 charging, that is AC/DC charging. This is level 1 and level 2 is AC charger, means AC power supply, and either you can with the home garage you can plug in, or you can have the public transportation, sorry, the public charging stations where you can plug in your vehicle. And if you want to go for a fast charging, then it is a level 3, which is provided either with AC or DC, and they will have the different power range. This is usually with the one or 2 kilowatt power, or maximum is 6 kilowatt power. This is with 10 to 16 kilowatt power range, and this is with a very high kilowatt power range. If you look at the Tesla Model S car, they will have in-wheel motor. They are using in-wheel motors, and this rear-wheel drive configuration in which the in-wheel motors are placed inside this wheel, but that is at the rear wheel side. And all-wheel driven configuration in which the drive, okay, sorry, here the motor will be external to the, it is not placed in the wheel. But if you will have the in-wheel configuration, then the motor will be placed inside this wheel. Here this is front rear wheel drive, and the all-wheel drive configuration in which two motors are placed, one at front end and other at rear end. Then this electrical vehicle and its infrastructure. So this is your vehicle part. Then, to have a continuous operation of your vehicle, you need to have the charging infrastructures. Along with these two compartments, you need to have one more system, which is known as a communication system. A proper communication system is required for appropriate to interface this vehicle with the charging infrastructure. So, an electric vehicle penetrates in developing countries requires the development of charging infrastructures and a reliable communication system. The infrastructure of charging stations may or may not include renewable energy system. So, in short, I can say that these are the component or the infrastructure components for electric vehicle itself, then the charging infrastructures and the communication infrastructure. Proper communication infrastructure is very much required uh, because today's we are living we are living with the concept of smart city. Everything is smart. It means that if I want to charge my vehicle, then we have the appropriate, can say, we have an appropriate infrastructure, communication infrastructure. Sorry for disturbance. We have an appropriate communication infrastructure, which will, or you have to develop some app, and through that app you can find whether the appropriate charging station, uh, or you can say, because every vehicle will have a battery which has been manufactured by the different manufacturer, and so they have the different charging strategy as well as different charging connectors. So, if I want to charge my vehicle at external outlet, or you can say that charging point, then definitely we must have a certain we have to develop certain communication system along with the certain mobile app that will provide information related with whether space is available to charge your vehicle, then whether the type of connector which you need for charging your vehicle, whether that is available or not, and the nearest place where you can go for charging your vehicle. So all that informations must be communicated from charging station to vehicle and vehicle to charging station. And again, this vehicle owner has to provide their willingness related with the connection of this EV, or you can say the contribution from these EV to a grid under certain abnormal condition of a grid operation. And you can look like the electrical vehicle is a vehicle which uses electrical energy as a source. So I have shown here supercapacitor, battery, fuel cell. Maybe the three combinations will drive your vehicle, or maybe a single battery will drive your vehicle, or a supercapacitor battery can drive your vehicle, or fuel cell supercapacitor or fuel cell battery may drive your vehicle. So we'll have the different combinations of use of this energy storage device as well as the fuel cell to build your electric vehicle. And they are always provided with all the control converters, because the functionality of battery, supercapacitor, fuel cell needs to be controlled while transferring power uh, to a vehicle. And we have an electric motor. This electric motor will be provided with inverter, that is a DC to AC converter, and this is again a controllable one. A motor, you have to decide the appropriate control strategy for motor, control strategy for this converter and inverter to operate your vehicle efficiently. So if you look at the electrical vehicle and its infrastructure, if I would like to determine how much maximum amount of power that the vehicle is needed, when it is running on road, because this information is very much required to design your electric vehicle. So in that particular case, the most usable methodology, what we are preferring, is the simulation of or simulating the whole vehicle in a simulation environment based on the driving pattern or the driving cycle. This driving pattern or driving cycle is nothing but the input that this will provide. This driving cycle is nothing but it shows a relationship between the variation of speed with respect to time when your vehicle is running on road, which will indirectly provide information about the driver nature, the road conditions, and the traffic conditions. And that's why the electric vehicle power demand is not constant all the time or not following a specific pattern. It has always variation in the power demand. The reason is that all three parameters on which the power demand depends, or the vehicle operations depends, are totally non-linear. No one can predict the nature of driver. No one can predict the road conditions or the traffic conditions. So usually the simulation will be carried out with the help of a specific drive cycle, maybe a standard drive cycles, or maybe measured uh, online measurement of these drive cycles by running your vehicle on a specific area where more congestion is there, more traffic is there, and then you can generate this pattern with the different nature of drivers. Some drivers are calm in nature. Hello, I'm audible. Hello.
Ma'am.
Yes, madam. Audible. You're audible.
Yes, ma'am.
So this driving profile will provide the information related with the driver nature, road conditions, and traffic conditions. So once we will have these informations, we can completely simulate our vehicle, and we can find out that how much power that the vehicle is demanding. And based on the vehicle power demand, we can provide uh, uh, or we can regulate power through the energy storage system, as well as we can regulate the motor operation so that the vehicle can run at desired speed. So these are the basic, you can say, the compartment of a complete electrical vehicle, in which you will have the energy storage system, maybe a single or maybe a hybrid. And when it is hybrid, you need to have the energy management unit to manage power flow between the different sources. This hybridization is very much required. If you look at the today's scenario with the available battery chemistry, this hybridization of source is very much required to enhance the life of battery and to increase the driving range of the vehicle. Then this energy storage systems will get controlled through DC to DC converter, so that you can have the regulation in the power which has been demanded by your vehicle, and then that finally that power will be fed to the motor drive unit, where again you will have the motor and inverter. So you will have the proper controller which will be operated with the appropriate control algorithm to drive your vehicle. And this data has been provided. This input data will be through driving cycles and vehicle dynamics. This vehicle dynamics is nothing but how much amount of force that has been exerted or that is required to have the continuous movement of vehicle on road. So that will be interpreted with the vehicle dynamics. So based on these vehicle dynamics equations, we can find out the power demand and torque demand, as well as the speed demand of vehicle, and accordingly all this management unit and the individual controller for converter, for motor, and will be designed, and all these are again controlled through some master controller, because we will have the individual units. And if we are running this individual unit with the individual controller, then there is no synchronization, as far as the vehicle operation is concerned, and that's why we need to have the master controller. Master controller will regulate functionality or provide a command to regulate functionality of the individual unit of a vehicle. So this is a complete vehicle model which you can develop in the MATLAB Simulink environment to test your vehicle, and the same can be now built in real time also to test your system. But the sizing of your source, sizing of converter, inverter, motor can be first calculated with the help of these driving cycles and the vehicle dynamics and the type of vehicles. What type of vehicles you have? What is the weight capability of a vehicle, including passenger, then the frontal area, the radius of the tire, etc. So in more details, if we look at the configurations, you will have the electrical propulsion systems which will be provided with the brake and accelerations. Like in conventional vehicle also we will have the brake as well as the accelerator foot pointer. So this will be like in form of brake and accelerators, and you will have the electronics controller. This electronics controller will control your power converters, and based on this the motor operations will be initiated. Of course, along with this you will have the energy storage system, energy management unit, energy refueling unit, that is a charging of that energy storage system, and you may have certain auxiliary power requirement, that is for a power steering, temperature control unit, for lights as well as for AC. And if you will look at the communication infrastructures, or you can say whenever you want to charge your EV, you need to have the charger configurations. So this charger, this is the complete charger configuration, and that this charger will get a power from a grid, and you have to simply plug in battery to this unit. This is a battery charger, and this is a front end converter which is required to regulate the power at grid while providing a charging power to the EV batteries. Again, we may have the energy storage system which will be driven by the renewable energy source with the converter, which will save certain amount of energy in this storage system. And these are nothing but basically vehicle data. Whatever the vehicle data you have, that can be transferred to the can say the charging infrastructures and application for vehicle user also, that can be communicated through this cloud computing mode, and that way you can have the exchange of informations between the charging infrastructure as well as the vehicle itself. If you look at the operating characteristic of vehicle, the load power of vehicle varies randomly in real operation due to frequently acceleration, deceleration, and climbing up and down grades. And that's why the overall the nature of your load is like this. This is the load nature. And if you will divide these into two compartments, one is a dynamic power and other is average power. It means that the vehicle is always demanding average power as well as the dynamic power. This dynamic power is for a short period of time, while the average power is for a long period of time. So if I am using a battery to drive this EV, then definitely the battery size will be much larger, as because it has to supply these two power, average power as well as dynamic power. Of course, the amount of dynamic power will be very large. Amount of dynamic power is much higher than the average power requirement. But the average power requirement is for a long duration, while this is for this peak power demand is for a short duration. So if I am sizing my battery to supply this peak power also, then the size of battery will be very large. But the utilization of this battery size is not 100%. we're not utilizing full capacity of battery because for the average power requirement is very, very less compared to the dynamic power requirement. So this again leads to an uneconomical operation of a vehicle, or the overall efficiency of your EV will greatly reduce, as well as the cost will also reduce. The volume and weight of vehicle will also reduce. So it is always better that we should understand that what should be the power requirement of a EV. And here you can see that the power requirement will be decomposed into steady and dynamic component of power. It means that we need to have a source which will have the large energy capability and large power capability. Or this can be again defined in terms of energy density and power density. As I have already told you that the power requirement of vehicle is governed by these three factors: driver nature, road conditions, and traffic conditions. And you can the dynamics of electrical vehicle will be defined in terms of this total amount of force which is exerted on the vehicle when it is running on road, and that is nothing but acceleration force. Then the rolling resistance force that is provided by the wheels which is running, which is touching the road, and that's why we'll have the rolling resistance force is also there. Then the drag force, because the vehicle is running on road and it is maybe in opposition to the air or in support of air. So we'll have the aerodynamic force, which is given by half rho A C D V minus O V W, that is a wind speed, and mgv sine theta, uh, that is nothing but related with your force when the vehicle is running on certain slopy road. And this is Fm m alpha into v. This is nothing but the acceleration force, because alpha is nothing but your vehicle acceleration. So the total power demand will be defined by these four factors, out of which this Fm m alpha v, that is acceleration power requirement, is for a short period of time, while these two forces, rolling resistance and aerodynamic force requirement, is for a very large period of time. And this the you can say the slope power requirement is again not continuously required unless and until you are operating your vehicle on hilly area. So main basic opposing force which the vehicle has to continuously supply is rolling resistance force and aerodynamic force. And this aerodynamic force is directly proportional to the cube of the speed, and that's why when the vehicle is at higher speed, the contribution with the aerodynamic force will be much larger. So based on this force calculation, we can say that what type of energy storage system that you need for EV. So energy storage system will play a key role in electric vehicles. The energy source is the heart of an electric vehicle. Two factors fundamentally characterize the application of electrical energy storage system. The first is the amount of energy that can be stored in the device. This will determine the range of your vehicle, how many kilometers your vehicle can run, and the rate at which the energy can be extracted. And this will determine the acceleration mode operation. And these two terms will be identified in terms of energy capacity and the power capacity. So presently we don't have any energy source which will have both the characteristic together. That means high energy density as well as high power density. So the source may have high energy density or high power density, but not both. So you can see like this the power and energy requirement. What is difference between power and energy? Power means it is in terms of the bulk amount, and energy means in a very you can say the small amount of power we are taking from the system. And that's why energy is always related with the long term and power is related with the short term. So the energy storage systems which we need for these applications are mechanical based, electrochemical based, and electrostatic based. That is a flywheel, batteries, and supercapacitors. But the most prominent technology which we use for EV is the batteries, and the second prominent is a supercapacitor. Of course, the flywheel may be used, may not be used because it has a certain disadvantage, or if any failure occurs, then that will create threats to the operation of EV. And if you will see the how to select your storage technology, in terms of the lead acid battery, 100 kilojoule per kg. But if you compare it with the gasoline, it is 43,000 kilojoule per kg. The gasoline will have a very high energy density, but the problem is with the engine that it operates with very low efficiency. And that's why we are not able to utilize this energy for vehicle operation. In case of lithium-ion batteries, it is 600 kilojoule per kg. So it varies with respect to the different types of energy storage technology. So what is the requirement for EV batteries? That the following the battery characteristics are required for electric vehicle. It has a high energy density, high power density, high cycle life. And I have mentioned in the bracket that it determines range, determine top speed. High cycle life will determine the life of your vehicle, and high nominal voltage determine how many number of cells that you need to have to make your battery module. High Coulombic efficiency is again important, low cost and low operating temperature. That means it should operate efficiently in low temperature. But if you look at the characteristic of battery, the battery will always operate at very, you can say, at the battery performance is very good when it is operated within the temperature range of 25 degree to 40 degree. But if you will go below or above or even with the below 0 degree temperature, the performance of battery can deteriorate. So it must have the low operating temperature range. If you look at the comparison of various secondary batteries which are available in market, the most popular configuration or the chemistry which is you preferred for EV applications is lithium-ion battery. Even they prefer to have the sodium sulfate battery also, but usually the sodium sulfate battery is used with the connection of this EV with the microgrid, where you have a renewable sources like a wind generator. All other nickel, molybdenum hydride battery, lead acid battery, nickel cadmium battery. So many other battery chemistries are there, but most popular is lithium-ion battery. Even in lithium-ion battery also, we have a different configurations. And if you look at the life cycle, the lithium-ion battery will have a good life cycle, 1200 to 2000 life cycle. That means this life cycle is always defined in terms of how many number of charge discharge that each storage device can perform efficiently. If you look at the batteries in the different EVs, starting with the 30 kWh, 16 kWh, 23 kWh, 16.5 kWh. 2 days, if you look at that, the EV batteries which are available is 64 kilowatt hour battery is available. And the car life expectancy can be calculated in terms of the driving range into the life cycle. If they have mentioned that 500 life cycles are available and the driving range is 4,000 miles per one charge, then the car life expectancy in terms of the mileage can be defined in terms of 2 lakhs. 2 lakhs miles. When it travels up to 2 lakhs miles, the efficiency, or you can say the life expectancy of battery can be assumed to be 100%. The most important part with the battery, because battery is the main source for driving EV, so the battery aging will play an important role. So you should be very careful about. You must have that knowledge that how the battery aging will take place. So battery usage is in the product of age, cycle count, charge speed, load level, and temperature. It depends on all that. So lower charge voltage and the cooler temperature prevents a lithium-ion battery when not in use. So whether the vehicle, the battery is in use or not in use will also define the battery aging phenomena. So based on that, we'll have the calendar aging and cyclic aging. Calendar aging means we are not using battery, not in use, and then how the aging will take place in a battery. And cyclic aging means when the vehicle is in operation. So if you look at the calendar aging is mostly depends on the temperature as well as the state of charge. So if the state of charge of your battery will be high, in that case the capacity loss will be more. This is the calendar aging, as I have told you, defined as the aging of battery during a storage when we are not using that battery. In these conditions, the parameters considerations are the temperature and SOC. So this is the all the graphs will be drawn with the hello.
Yes, madam.
Okay. So with 25-degree temperature, you can see that the capacity loss will be very less. So it is more preferable to the calendar aging is with the temperature. More you can say. Hello, I'm not audible. Okay. So in case of cyclic aging, usually we have the grace capacity will be defined by 20% on the top margin as well as on the bottom margin also 20% as a grace capacity. And as the vehicle start utilizing this battery, then with the when it travels 75% kilometers, the grace capacity get reduced by 5%, and when it travels 1,50,000 kilometers, the grace capacity will now reduce by 12%, and when it reaches to 2025, 2,25,000 kilometers, the grace capacity has almost become zero. And as we move ahead, then the below grace capacity will be utilized, and 30% and 40%, and at that time, the required kilometer range can be obtained by charging your battery to the full rate, that is 0% SOC to 100% SOC. And this has been explained with the specific range, that is 250 kilometer per cycle. So up to here you are able to achieve 250 kilometer per cycle, but at that time the capacity is hardly of 60%. And as what I have told you, that means the battery size has been designed in such a way that 60% of its capacity can provide 250 kilometer range per cycle. So this way your breast capacity reduces as it travels more and more kilometers. So in other way, I can show you with this that when you will have the new battery, spare capacity is up to 30% on the top side and 20% on the bottom side. When for the same kilometer range that has been mentioned, and when it reaches to the midpoint, on this side the spare capacity is 90%, only 10% we are not utilizing, and here it is moving to 20%. And when it is end of life, then the spare capacity is between 0 to 10%, only the top capacity has been already utilized. It means that it requires more power to charge your battery to cover the same amount of range, that is 160 kilometer driving range. So the new battery charges up to 80% SOC and discharge up to 30% SOC. Batteries with half-life cycle can charge up to 90% SOC and discharge up to 20% SOC. So as the range of SOC increases, the amount of power needed to charge your battery will also increase. And at the end of life, it can charge up to 100% SOC and discharge up to 10% SOC to achieve the same 160 kilometer driving range. So this way you can say that the battery aging will play an important role, and based on considering this battery aging, you have to design battery parameters accordingly. So you can say that the precaution with the battery, that is, a car battery size is decided by range, that is reduced by 30 to 37% to include other additional load along with the driver nature. The cold temperature reduces driving range. Lithium-ion battery cannot be charged below freezing point. A low freezing temperature charger power must be reduced. Otherwise, it leads to the anode degradation. It means that if you are charging your battery at low freezing temperature, you have to reduce the current rate, the rate at which you can charge your battery. At 50 degree also, the charger power must be reduced to save the battery. The life is prolonged if operated at mild temperature. That is what I have told you, that 25 degrees. The combination of low cycle depth and low SOC leads to a great larger battery life. So if you are not discharging your battery and with respect to their SOC, then definitely we are able to increase the battery life. But we have certain limitations of battery, that is poor efficiency, low power density, short life cycle, low operating range, and low current capabilities of batteries are our main limitations. So we are facing these limitations. This unwanted characteristic limits the performance and desirability of electric vehicle. So this power demand is supplied by the combination of two storage devices, which are nothing but batteries plus supercapacitor. As the battery can provide average power or the normal power, and supercapacitor will provide dynamic power. Because this supercapacitor is a high power density device, while batteries are high energy density device. So if we will combine these two, we are matching the vehicle characteristic in terms of high energy density and high power density. Today I'm not going to tell you more about supercapacitor, but the name ultra or supercapacitor tells that this capacitor will have a very high value of capacitance, but it is suffering with one limitation, that its operating voltage is very less, 2.7 volt. This is the limitations, and people are focusing or doing more research in this field to increase the dielectric breakdown strength of the electrode materials which is used to design this supercapacitor. And people might have achieved that range in terms of 5 volt also. But along with that, the power density of the supercapacitor may get reduced. The beauty of the supercapacitor is that it doesn't operate with a chemical reaction. And that's why the energy storage capability, the power storage capability of this device is much higher, as well as you can charge and discharge this device a more number of times, thousands of the cycles are available, and you can charge at any current rate, which is not the case with the battery. You cannot charge your battery at any rate. That is a limitation of battery. So this way, the supercapacitor is more superior. Uh, the basic construction is almost similar to the conventional capacitor, having two electrodes, and they are separated by the small charge separation, that is 10 angstroms, and thinner dielectric. They are available in form of cell, and they are available in form of modules. It can even operate at a temperature range of minus 40 degrees centigrade to plus 65 degrees centigrade. It requires minimum maintenance, relatively high abuse tolerance to overcharge and over temperature. This is the most important part related with the supercapacitor. Rest of the things I will discuss in my other lecture. But you can see that it is known as a double layer capacitor also, and these two layers are formed at each electrode, positive and negative electrodes, and each electrodes will offer certain amount of capacitance. And that's why the two capacitance are like connected in series. And these resistance which has been shown over here, they are nothing but the parasitic resistance offered by the electrolyte, the connectors, etc. And as I have told you, that the charging and discharging behavior of battery is like this, and that's why the hysteresis effect will be generated, which is not the case with the supercapacitor. It follows the same path, charge and discharge path will be same. And even usually we prefer to have the Ragon chart, and this Ragon chart will provide energy density versus power density. That means certain device will have the high energy density, then the low power density, and certain device will have the high power density but low energy density. The power density and energy density of supercapacitors has been provided by the manufacturer, or even they have given this formula, you can calculate it. But if we look at this with the high current capability, that the maximum current capability may vary from 680 ampere to 1900 ampere. And in this particular case, if you look at the size of or the weight of this particular supercapacitor is very, very small compared to battery. And this peak power saving can be achieved with the help of supercapacitor. Let's say this is the available power, and this is, you can say, the required power. In that part, this peak power needs to be supplied, and that has been supplied by the supercapacitor. Even it can absorb that energy. Even it can absorb that energy at any rate, which is not the case with the battery. Application of supercapacitors. one, the most appropriate application, that is a regenerative braking. As we all know that the in electrical vehicle we can run the motor as a generator, and when it runs as a generator, whatever the stored kinetic energy you have in the wheels of rotating wheels of vehicle can be transferred back to the supply system. It can be used for backup power in any applications where the quick discharge or the charge is required. Then the second element, which is most important, is what type of electric motor that we need to drive this electric vehicle. So this electrical propulsion system which we need is like a small in size with the short action length. That is one of the requirement, that the size should be small and must be able to deliver required amount of torque, high efficiency and high power density, high torque at low speed for starting and climbing, very wide speed range including constant torque and power region operation, high efficiency over wide speed and torque range, fast torque response. These are the basic requirements of electric motor, and it must operate at high reliability and robustness for various vehicle operations and conditions. And the most important part is a reasonable cost. Reasonable cost with the inverter topology. So as far as the electric availability of electrical motors for EV is concerned, we have the commutator and commutator-less motors. In commutator motor, usually we'll have the group of motors known as a DC motor, series or shunt motor, maybe self-excited or separately excited. When it is separately excited, it may be a permanent magnet excite motors, or the field excited motor, or self excited motor can be further divided into part, series and shunt part. And the commutator-less motors are nothing but the induction motor, synchronous switch reluctance motor, BLDC motor, permanent magnet. So these are the different motors available for EV. And today's the moment is towards the use of induction motor, as it doesn't require any uh, magnet. And one more trend towards multi-phase motor operations, because if suppose we have three-phase motor and one of the phase may not in a working position, then to drive a, if you have a more if you will have the more number of, you can say, so if you will have a more can say the more features of motors which are not dependent on the permanent magnet, then the type of motor is more preferable. With higher number of phases, it will provide continuity of operation. This is the most important part, is that it provides continuous operations, even of course at lesser power rating or lesser rated capability. You can drive your vehicle at lower speed, but your vehicle can run on road. And if you look at the vehicle characteristic, this is the first figure, shows that this is a vehicle characteristic in which the torque portion, constant torque region part is very small, but almost your vehicle is operated in constant power region. But now if you look at the motor characteristic, then it has a constant torque region and constant power region. So if the constant torque region will be larger, and if we are not able to operate the can say vehicle in constant power region, then definitely the motor rating will greatly increase in terms of its torque requirement. But almost you can say that the characteristic of vehicle is matching the characteristic of EV. EV motor. So if you look at the induction motor characteristics, the torque, constant torque region, and then after it operates in the, you can say, constant power region, with the speed is directly inversely proportional to the torque. And in the second part, that is stator voltage, we are keeping fixed. We are not in position to change the stator voltage. And this region is a high speed region, in which all control will be provided through the control of slip. That is a controlling the functionality in a high speed range or high power range. Then we have the PMSM. Of course, the PMSM motor is more preferable, but if you look at this torque characteristic, constant torque characteristic will be more dominant than the constant power requirement. Of course, the PMSM motors are proven to be very highly efficient motors for EV application. Then the next candidate is SRM, switch reluctance motor, synchronous switch reluctance motor, and these motors are again more preferable. The reason is its control is very simple. Individual phase can be controlled individually, and that is the main beauty of this, and its characteristic is almost matching the torque speed characteristic of vehicle. But still it is suffering from certain disadvantage. One of the disadvantage that is related with the, it produces lots of noise, and it is not in position to have a torque with minimum ripple at the output of the motor. So this is the disadvantage. Otherwise, it is the most simplest configuration of motor. Other advantage that the EV can offer is efficient regenerations. EV can recover energy during deceleration, braking, and climbing down. So motors can act as generator, and mechanical energy is converted to electrical energy, which can be driven back to the battery. So in a reverse way, this is also possible. So needs motor design to recover as much energy as possible, need vehicle battery charger to compare to capture as much recorded energy as possible. So in what we say that we can go up to the highest amount of regenerative braking, but not up to the 90%, because vehicle will then only use energy to overcome rolling resistance and aerodynamic drag. Most acceleration and climbing powers can be eventually recorded. So in short, you can say that we are in position to generate more amount of, or we are able to return back the utilized power back to the energy storage system. Hello, I am audible?
Yes, ma'am, audible.
Now, these vehicles require power to run, and that power we have to save into our energy storage system. So we need to have the appropriate charging infrastructure. And this particular diagram shows a charging of electrical vehicle using smart grid. You know the meaning of smart grid. Smart grid means it provides a power flow in both the direction. Previously, it was not the case. The power will only flow from grid to the load. But when we interface EV with the power grid, then we must need to have that facility that power can flow from battery to, or EV battery to grid, or grid to EV battery. So one is charging, other is a discharging process of a battery. And even we can use this renewable sources also to charge that battery. You can have the plug-in facility at home, or you can have the plug-in facility at different charging points available in the city area. Charging infrastructure for EV, every resident should be provided with charging points. Office building, parking place should be provided with EV charging points with smart meters. Why the smart meter is required? Now we have the power flowing both direction. Either EV is getting power from a grid or EV is supplying power to the grid. So in that particular case, we need to have the two different meters. One meter is needed when the power will be taken from the grid, and the second meter is required when the power is transferred from battery to the grid. So, and in that way, the consumer is getting certain incentives from the government or energy generating company. Battery charging stations should be provided with the battery swapping facility and charging facility with the same smart meter. So this is again another option. If suppose you don't want to say the battery, when you charge your battery, the the life cycle of battery always depends on at what rate you are charging the battery. So even if the manufacturers are provided that you can charge your battery at this particular rate, this will also affect the battery life. So in that particular case, if you want to charge your battery with a long time duration, then the concept of battery swapping is come in picture. The battery swapping is nothing but whatever the battery the vehicle owner has when it is running its vehicle on road, and when it reaches to the exhausted mode, then you have to approach the charging station people, and charging station people will provide a swapping facility. That means you can submit your actual battery available in battery which get exhausted to the charging station owner and take the new battery. So that process we call it as a battery swapping process. Fast DC, again we'll have the fast DC charging station should be developed in near future with joint venture of government and stakeholders. We'll have the different charging methods. One, as I have told you, the level 1 charging, that is 1.5 to 3 kilowatt. And usually the plug-in facility is with a 230 volt AC, 6 ampere. It means that it can be, you can charge your vehicle at home also. Level 2, 230 volt, 30 ampere, two pole hookup, reassembling household dryer to charge mid-size EV in 4 to 5 hours. And in level 2, the power range will be 7 kilowatt range or even little bit higher. But if you look at the installation cost, will be about 3,50,000. But level 2 is a medium level of charging procedure. At level 2, when you charge with the level 2, when you charge your battery, it is a medium level charging strategy. And level 3, that is level 3 is a DC fast charging or a AC fast charging, which delivers 400 to 600 volt DC and up to 300 ampere. It bypasses the onboard charger uh, and feeds power directly to the battery. Level 3 chargers deliver up to 120 kilowatt to fill a lithium-ion battery to 80% state of charge in about 30 minutes. So installation cost of nearly 10 lakhs and higher per station. So it depends where you are installing this tower. If you look at this different charging level, which I have told you, with the higher current range, higher power rating, etc. You can have the facility to charging at home. Most owner will charge vehicle at home making level 1 and level 2 the primary options. And level 2 charging equipment now costs to $1,500 to $2,500, and installation requires permitting and license contractors. So this is that means they are allowing you to establish these charging stations and license of the contractors. And charging in public, that is a charging public station, public charging stations makes EVs and PHEV more convenient and increases the fuel range. That means you get increase your range because you are able to charge in between. And public charging infrastructure locations, shopping center, city parking lots, airport, hotels, and office buildings where you can charge your battery bank. If you look at the charging stations for EV at Delhi, it is a solar-based charging station. The power they are getting charging power through solar. This is a solar power charge car charging station, and that has been developed not in India but in USA. And the resident in the urban area in USA has to pay around 2.30 30 per month on fuel by a normal fuel. But if they use electric vehicle and charge their car from the grid, their monthly drop to $107. It means that it is always beneficial if you charge your vehicle with the non-conventional source. Then what are the EV hurdles? As we have seen a lot many advantage offered by the EV, then why still the EV is not penetrated in the market, especially Indian market? The key challenges that has been identified are the low vehicle performance, inefficient battery, high charging time of batteries, and range for single charge, and lack of awareness among the public. That means we have to create awareness program to educate people to have a concept of EV and buy EV and use EV. Anxiety over the technology of EV regarding safety. This is again a question markable part, that we need to have the safer operation of vehicle. The Indian components and the vehicle manufacturers are also likely to face the same situation like other countries, where in the initial phase the volume will be low and not justify the investment requirement. But of course, in the initial phase, the volume will be low, but as the time goes on, this volume further increases. The solution of range anxiety, like if you will look at this, the energy density, whatever per kg in 2011, it was 80, 2015 it is 140, 2018 to 20, and now 2020 it has reached to 310 whatever per kg, and the cell price has been now reaches to 110 per kWh. So you can say that the development of the energy sources with the higher energy density to enable fast charging. As the battery will have a high energy density, high power density, you can charge at higher rate. Then there is a development of charging infrastructure and reduce the weight and volume of the cars by reducing size and weight of the component. So what we need to do is we have to reduce the overall size of vehicle. I have told you about the battery swapping, and this picture shows that how the battery swapping will take place. Then what are the EV growth? factor driving the growth of electric vehicle market in India is one of them is government in initiatives, and that government initiative has been taken in form of you can say national mission for for e-mobility, national electric mobility mission plan 2020 that has been announced by the government of India. Along with that, they are providing certain incentives for the buyer and the manufacturer of EV. Other growth factor for the EV is rise in fuel cost, low operating and maintenance costs, foreign dependency for crude oil, environmental friendly nature. Unlike other countries, the Indian passenger car market is predominantly a small car one. So India has a huge two-wheeler proportion populations, and the country is the world's second largest manufacturer of two-wheelers, because we are using that two-wheelers in large capacity. Other drivers are, as I already talked about the 20 cities, and out of that, the 14 cities are uh, 14 cities will be 14 cities are highly polluted cities. Large-scale penetration of EV will require both demand-side incentives, that is, tax incentives to the manufacturers, and improved charging infrastructure, as well as the integrated planning for distribution grid management. This is again the most important part. How we will manage your grid when you connect this EV, connect this EV battery with the grid for charging. EV offers opportunity to act as a distributed storage in the urban energy system, which could help in better integrations of intermittent renewable like wind and solar, and can feed the grid at a peak time. It means that they can support the functionality of this non-conventional source. And it provides not only the G2V facility, G2V is nothing but the grid to vehicle facility, and V2G is vehicle to grid facility. So, as far as this bidirectional mode functionality is concerned, this will further increase the overall efficiency of battery operated electric vehicle. The National Electric Mobility Mission Plan was launched with its main objective as to increase the adoption of EV in India. The government of India has set an ambitious plan targeted for 100% adoptions of EV by 2030. And faster adoptions and manufacturing of hybrid electric vehicle India scheme was launched for faster adoption of EV amongst consumers and to establish India as manufacturing hub for electric vehicles, and thereby incentives were provided by Department of Heavy Industries. And they have provided incentives in the paper in newly outlet of 10 crores over a period of 2 years. It has been provided by one and two. And there is a major government policies also required. Government has decided are to put approach to the customer adoption and manufacturing of electric vehicle scheme, which aims to benefit Indian industries and users. And assuming all vehicles eligible for FAME 2 incentives are deployed, the net saving would be 5 million tons of oil equivalent and 7 million tons of CO2. It means that we are able to save a huge of CO2, and that means reducing the CO2 consumptions as well as saving the fossil fuel. And if we look at this, the 27 states have formulated strategies for transforming their mobility systems, and several states have formulated or in the process of formulating their EV policies. And these are the few incentives provided by the FAME 2 that is 5 lakhs e-rickshaws having expected price up to 5 lakhs with an incentives of 50,000 each, 2.5 lakhs in incentives to the two-wheelers, and 13,000 to 20,000 incentives to the hybrid four-wheelers with the expected price up to 15 lakhs. And they have provided the subsidies even for the e-buses in the range of 50 lakhs up to 2 crores, uh, and 1.5 lakhs income tax reductions on interest payment on loan taken from the or taken for purchase of EV, and GST has been reduced to 5%. Custom duty in various parts have been again exempted. So these are the few incentives provided by the government of India under the FAME 2 scheme. Certain industry initiatives is also required to have R&D in the field of a different compartment of EV, especially lithium-ion battery manufacturing plant. And if it is successful, FAME 2 is beginning, not an end. Therefore, the report also quantify the catalytic uh, effect that FAME 2 could have on overall EV market. If FAME 2 and other measures are successful, India could realize EV cell penetrations of 30% for private car, 70% for commercial car, and 40% for buses, and 80% for two and three wheelers by 2030. So this is the FAME 2 policy goal, and it is expected that by 2030 it could generate cumulative saving of 846 million tons of CO2 over the deployed vehicle lifetime. That is, for a given lifetime period, this much amount of saving is possible. And these are that calculations which I have already told you. This too is related with this. And further improvements for adoption of EV, we need to take certain measure steps. For a fiscal purchase incentives to be effective, consumer needs to have the range of product options in the market. This is again important things, that only the competitive market is available and we can get a vehicle at lower price. The development of charging network is essential to the adoption of electric mobility. And as far as this charging network is concerned, government has declared its plan in terms of at every 20 kilometers on highway, on both the sides of highway, we have a charging station. And these charging stations may be from renewable sources. Promoting awareness of electrical vehicles in critical steps in creating demand. This is the most important thing, that we have to create awareness amongst consumer. We have to tell them that okay, the electric vehicles are more beneficial, and in long term, what you are gaining and the running cost of the vehicle is very, very less. Focusing on shared and public transport has a higher overall impact than focusing on private vehicles, even with the electrical vehicle. Battery vehicles should be incentivized in proportion to their efficiency, range, battery life, and other performance criteria. This is the most important thing which is missing in FAME 2, that we have to, the incentives should be given in a proportion to their efficiency, range, battery life, and other performance criteria. Low quality batteries do not become the largest beneficiary of FAME 2 funding. No funding should be given to those type of batteries. Linking FAME 2 incentives to battery capacity provides motivation to customers and manufacturers to shift towards long range vehicles. So I think these are the, you can say, uh, the further improvements for adoption of EV. And again, it is with the public transportation, putting more emphasis on the public transportations, which will further improve the, you can say, the efficiency of EV. Then again, go for different charging models. Traffic congestions will worsens with lengthy queue. So we have to decide appropriate charging model also, so that people can do not have to wait for that. Like the way we have the filling of oil tank within 2-3 minutes, we may provide a battery swapping facility. So within 2 to 3 minutes, the swapping of battery will be there, and the car operator can immediate car user can immediately get the new battery and continue with its journey. The financial incentives to the investor, including maximum cash subsidy, would be for up to 20 gigawatt hour per firm, and 2000 cash subsidy will be for 1 kWh only for 100% domestic value capture. So these are the few incentives which has been demanded for further improvement of with the adoption of EV. And there must be a relaxation in the GST also. And these are the certain recommendations that adequate capacity additions primary to renewables in the distribution grid in order to meet the additional demand created by the high penetration of EV. EV charging stations to be designed preferably with the rooftop solar generation to minimize dependency on the fossil fuel in entire supply chain, shifting towards clean energy. Encourage EV manufacturer to design vehicle with changeable batteries so that EV owner can just move in the charging station, replace this battery with the fully charged battery and move on. Charging stations can plan to charge the batteries during off-peak time at reduced electricity tariff or direct from rooftop solar power. So these are the few recommendations to deploy more EV on Indian roads. And as far as the researchers are concerned, there are current research area, that is energy storing system, power electronic system, drive system, vehicular dynamics, development of charging infrastructure, smart and connected vehicles. So these are the different areas in which people can focus. And mainly, I can say that more focus on R&D, startups, and Make in India helps to preserve India's GDP, and it provides future is really we have. I'm appealing a student to do more research in the field of EV so that we can help environment, or in short, we can help the world, the overall, and we are improving the life lifestyle as well as the health of citizen of the whole world. Thank you so much. If you have any questions, you can ask me.
Thank you so much, madam. Very informative and very deep. Test. Thank you so much. Feedback.
Hello, good afternoon, madam.
Yeah, good afternoon.
Ma'am, what is the scope of batteries in the case of EVs? Because we are reading that the material which is required to develop such kind of batteries are very limited. So in that case, what would be the solution of the nearer future?
They are moving towards solid state battery, right? And the sodium based battery also they are moving towards this. And of course, we have the limited resources available for battery, but I think the lithium ion battery chemistry is the most popular battery chemistry. And people are moving towards certain other electrodes, or you can say the hybrid electrodes, so that they can improve the functionality of battery. But still, we do not
Okay, ma'am.
have any other, you can say, the resources which can replace your battery. Of course, we have the other resources like a flywheel and the supercapacitor, but they are only for a short period of time. They provide power
Okay,
for a
thank you.
short period of time.
ब्रश भी नहीं की करते हो आप सुबह ब्रश कर लिया करो आप
Hello, ma'am.
Yes.
Can you suggest or name some industries those who are involved with EV specifically for the two-wheelers? Looking towards up to 2030, which are the industry right now working in the area of this two-wheeler sections?
Of course, there are many industries. You can look at the hero. Then we'll have. Actually, I have forgotten the names of the industry, but multiple number of industries are available in market, which provides or which are working in the development of these two wheelers. And most of these companies are the startup companies. If you will look at the Surat, in Surat we have so many startup companies are there. Actually, I do not have the just now in my hand that information with me, but so many number of companies are there. And if you want it, I will send that information to the coordinator, and you can collect that information. I am having the list of that companies with me, but not now with my laptop just now. So there are many companies, but mostly the startup companies. They go for manufacturing of two wheelers, even a cycle, electric cycle.
Thank you, ma'am.
Good morning, madam.
Yes.
Hello. Can you,
Hello.
madam, can you suggest some course to learn complete mathematical modeling of UV and motor selection related stuff, madam?
You can go an NPTEL course.
Okay, okay. That is a electrical vehicle technology course. There is a name.
Yeah, placed by Dr. Praveen Kumar from IIT Guwahati.
Okay, ma'am. Okay, ma'am. Thank you,
You
ma'am.
can refer that.
Okay.
For what purpose? Say when I am connecting battery with the grid, right? Then the power is delivered from grid to the battery. This is a charging mode of battery, in which the battery gets charged. Then the other mode of battery is when your battery is fully charged and not taking any power from grid. And if suppose the grid is demanding peak power, then you can operate this battery in two mode. Either it can support the real power demand of a grid by discharging battery and transferring power from battery to the grid. This is one thing which is not preferable mode, and consumer or the car owner may not be agreeing to supply that power because it will ultimately affect the life of battery, the charging cycle of charging and discharging cycle of battery. That is one thing. And second thing is you can use battery charger to provide reactive power compensation. So many times there is a voltage fluctuations. So that voltage fluctuations can be supported by this charger in terms of supplying a reactive power. And that for that the consumer may agree because this doesn't require any active power from battery. So here in case of supplying reactive power, the role of battery is not there, but the role of the converter which we are using for charging or discharging of battery will come in picture, and they provide a certain amount of reactive power support. Of course, for that you need to have the appropriate design of your DC link capacitor. This is the most important thing, because ultimately this DC link capacitor will be a storage device to support this reactive power compensation.
Thank you, ma'am. Uh,
You can go up to 400 or 500 kilometers. The few new cars available in market, they are claiming that you can go up to 400 to 500 kilometer in single charge, but that is on paper. Of course, we have to consider certain other usages of that battery. That is the internal for internal operation of vehicle, and because of that, you may not get that range, but still it is possible to go up to this maximum range. Not right now, not right now, but the certain prototypes has been built and tested with the electric vehicle. Of course, still there is certain problems related with the SRM motor, which is in terms of you can say the torque ripple, commutation torque ripples, and the other you can say the while transferring uh, the switch operations from on to off and off to on, the commutation torque ripple will be there, and the normal torque ripple, that is in terms of the current drawn by the individual phase. But of course, the SRM motor is more preferable. You can run this motor at very high speed. This is one of the things, and that's why the motor power, can say the torque capability can be, if you will have the lower torque capability of motor, it can be preferred because the vehicle speed is not very high. So you need to have at least a single gear arrangement which can drop out your speed and enhance the torque demanded by vehicle. But the hurdle is with the torque ripple and the noise. Otherwise, the control of switch reluctance motor is very easy. Individual phase are controlled. Not like the in case of induction machine, you have to switch on the three phases at a time.
uh,
Um,
Um, I do not have the exact information, but still, I think this is at the research stage, and of course, as far as the can say the battery manufacturing is concerned, still the India is lagging with that. Even for the other chemistry also. Maximum what people are doing is they are buying cell from the other country and they do the assembling operations. They build the battery management system, and they do the assembling of that cells to get a required power capability of a battery.
Madam, while reactive power compensation,
What is the maximum percentage of power rating that the charger can support to the grid, madam?
Of course, that has been decided by what capacity of charger you have. That much amount of reactive power, as that's why what I have told you, that you have to design appropriately. Once you know that, okay, this is the capability of your charger in terms of VA, or in terms of KVA, whatever way you define the power rating of your charger. Based on that much amount of energy, maximum that much amount of energy you can transfer. But again, it depends, because your system will have certain amount of losses, so you cannot transfer the full capability of your charger. That means that much amount of reactive power you cannot transfer. And again, it has been decided by the rating of your DC-link capacitor. This is the most important part, because DC link capacitor will have the capability of storing that ripple power which has been injected back into the grid. So how much amount of reactive power that you would like to inject in the grid, that depends on two things. One is a DC link capacitor design, and second one is on the charger capability in terms of
Thank
the
you,
application current rating.
Thank you.
What are the prospects of fuel cell based energy storage in comparison with ultra capacitor?
Fuel cell based energy storage system is more preferable, but still, so many, you can say, the limitations are there with the fuel cell system. Still, it is at the development stage. Still, we have not reached to the mature level of implementing this technology. The safety is one of the things. Then the storing of this hydrogen fuel in a tank with respect to certain pressures and all that. These are the certain things which still requires more research for its implementation. Still, we have fuel cell vehicle available in market, but still this technology is not that much matured. And one more thing is that the fuel cell operation is a little bit sluggish at the time of startup. When you start your fuel cell, it won't generate required amount or required level of power or required level of voltage immediately. So again, in that case, you need to have a combination of either battery or supercapacitor to support the functionality of fuel cell.
Okay, thank you, ma'am. Thank you.
And different, you can say, different types of fuel cells with their constructions are available in market for other applications. Even for power system applications also people are preferring. But as far as the vehicle application is concerned, it is moving on a road, and that's why the certain safety factor needs to be considered.
Hello, good morning, madam.
Yes.
Madam, I wanted to, if we consider 100% production.
Can you speak little bit loudly?
If we consider the present scenario of manufacturing EVs, how many percentage are using induction motors, and how many percentage the production are
Still,
of other motors?
yeah. Still, people are preferring, depending on your applications for a two-wheelers. Still, they are focusing on brushless DC motor, and for higher applications, they are preferring permanent magnet synchronous machine. Still, they are in demand, but I think the Tesla has started using induction motor. Even the Reva motor, which are manufactured in India, they are using induction motor. That means the use of induction motor is still less compared to the permanent magnet motor.
Means
But
BLDC motors are more used compared to induction motor, is it?
yes, still,
Uh, eh, uh,
especially for a two-wheeler application.
okay,
For two-wheeler
madam,
applications, they preferred brushless DC motor.
do you know, madam, if you can answer that suppose Tata Nexon four-wheeler,
Uh,
in that model, which motor is used? If you know, madam.
PMSM motor.
Okay, they are using PMS. Thank you very much. Thank you.
So I'm leaving. Okay. Thank you so much. Yeah.
Sir, if possible, you may share the content so that by day basis, so that it will be comfortable, sir. If possible, please. Yeah, sir. If possible, you may share the content on daily basis. It may be comfortable for us. If possible, you may do that, sir. Thank you so much. Okay, sir. Thank you so much. Thank you. That is enough, sir. Yeah, video link means that is okay. Thank you. Thank you, sir. Thank you.
Hello, sir. Yes, sir. Where is the feedback link, sir? I can't find in this chat box. Okay, okay, fine. Thank you, sir.
Is there any feedback I'm using? Is there any feedback in? Okay, okay, okay. Thank you, sir. Thank you.